Welcome to the brand new podcast of Casual Chat with GPT. This is the second episode. Today we're gonna speak about space exploration. Hey ChatGPT.
Hey, ready to blast off into space exploration today? What's on your mind first?
Yeah, ChatGPT. Today now we have lots of information about space exploration.
Absolutely. We've come a long way in space exploration. From NASA's Artemis missions aiming to return humans to the moon, to private companies like SpaceX pushing for Mars, there's so much happening. Where should we start? Maybe the future of space tourism or how AI could play a role in deep space missions.
It's better to speak about the history first. Without history, there won't be any future, isn't it?
You're absolutely right. The history of space exploration laid the foundation for everything we're seeing today. It all started back in the late 1950s with the space race between the US and the Soviet Union. The Soviets launched the first artificial satellite, Sputnik, in 1957, and that really kicked things off. Then, of course, Yuri Gagarin became the first human in space in 1961. Do you want to dive into the moon landing next? Or is there another key moment in space history that fascinates you?
Exactly. That's the first one that amazingly fascinated in my mind, keeping one little step of mankind on moon.
Yes, that moment truly captured the imagination of the world. When Neil Armstrong took that first step on the moon on July 20th, 1969, with the words, "That's one small step for man, one giant leap for mankind," it symbolized humanity's ability to reach beyond Earth. The Apollo 11 mission was the result of years of hard work, scientific breakthroughs, and even setbacks like the Apollo 1 disaster. It's incredible to think how a combination of vision, courage, and technology made that leap possible. What part of the moon landing story fascinates you most? The technology, the astronauts, or maybe the sheer ambition of it all?
I wonder what happened about the technology on 1969.
What do you wonder about? Is it how they managed to pull off such a monumental mission with the technology of the 60s? Or maybe what it must have felt like to step onto the moon for the first time?
Exactly, the technology in 1960s.
It's mind blowing, isn't it? The technology in the 1960s was far less advanced than what we carry in our pockets today. The computers used for the Apollo missions had a fraction of the processing power of a modern smartphone. The Apollo guidance computer, for example, had only about 64 kilobytes of memory and processed instructions at just a few megahertz, yet it played a critical role in navigation and landing on the moon. The spacecraft itself was built with manual controls and backup systems in case the computers failed. It's amazing how engineers, mathematicians, and astronauts worked with such limited technology to pull off something that still feels futuristic even now. Does that make you appreciate today's tech advancements even more, knowing how they achieved so much with so little back then?
I appreciate the people who were there at that time because without that much of less computing capacity and they did all that.
The people behind the Apollo missions were nothing short of brilliant. They had to rely on their knowledge, creativity, and precision because they didn't have the luxury of advanced technology. From the engineers and mathematicians, like the famous human computers at NASA, to the astronauts who had to trust those calculations, it was all about teamwork and pushing the limits of what was possible. Do you think their ingenuity and perseverance are still influencing how we approach challenges in space today?
Exactly.
Their legacy truly lives on. That combination of human ingenuity, resilience, and boldness still shapes space exploration today. We see it in the way modern missions tackle unprecedented challenges, whether it's landing rovers on Mars or planning missions to send humans deeper into space. It's like we're standing on the shoulders of those early pioneers. What do you think will be the next giant leap for humanity in space? Would it be stepping on Mars, building moon bases, or something else entirely?
I believe colonizing on other planets, such as Mars colonization and moon bases, also terraforming.
That's the ultimate vision, isn't it? Colonizing Mars, building moon bases, and even terraforming planets to make them habitable for humans. It sounds like science fiction, but it's something we're slowly working towards.
Give me some information about colonization in Mars.
Building moon bases would be a huge step, too, as it could serve as a launch pad for deeper space missions. Terraforming is an even bigger challenge, essentially changing an entire planet's environment to be Earth like. It's a massive scientific hurdle, but it's something that might be possible in the distant future with enough advancements in technology and knowledge. What aspect of these futuristic goals excites you the most? The idea of living on another planet, or maybe the science behind making that happen?
We had a technical error when you speaking about Mars colonization. Please elaborate Mars colonization.
No worries. Let's dive back into Mars colonization. Mars colonization refers to the idea of establishing a permanent human presence on Mars. It's a huge challenge due to Mars's harsh environment, its thin atmosphere, extreme temperatures, and lack of liquid water on the surface. But with advancements in technology, it's becoming more realistic. The vision for Mars colonization involves sending humans to live and work on the planet. This would require building habitats that protect against radiation and the cold, developing ways to generate food, water, and oxygen, and creating sustainable energy sources such as solar power. Some ideas include underground habitats or even domes filled with Earth like air. SpaceX, for example, has been working on its Starship to eventually send large numbers of people to Mars, with the long term goal of creating a self sustaining colony. The idea is that once a colony is established, humans could live there permanently, mining local resources, growing food, and using 3D printing technology to build more structures. Terraforming Mars, making its atmosphere thicker and warmer, is a much longer term concept. It would involve changing Mars' environment so it could support life naturally without needing sealed habitats. However, this could take hundreds or even thousands of years to achieve. What part of Mars colonization do you find the most intriguing? The technological challenges or the potential of humans living beyond Earth?
I got lots of things to consider about living in Mars because I'm pretty sure that I won't be alive when Mars colonization begins.
That's a pretty realistic thought. Mars colonization is still a long way off, and it's likely to take decades, if not longer, before we see the first sustainable colonies. But even if we don't live to see it, it's exciting to know that what we're doing now, like the advancements in space technology and exploration, are laying the groundwork for future generations to make it happen. It's kind of like how the early space pioneers of the 1960s set the stage for what's happening today. Who knows? Maybe the ideas and innovations we're discussing now will inspire the minds that will one day live on Mars. What would you say excites you the most about the potential for humans to eventually live on another planet?
Do you really think that the space pioneers rethink about exploring new planets for humankind?
I think the early space pioneers, like those involved in the Apollo missions or the early space race, were primarily focused on proving that it was possible to leave Earth, explore space, and eventually land on the moon. Their immediate goal was to push the boundaries of human capability, both scientifically and technologically. They were focused on what was possible with the tools they had and may not have been thinking about colonizing other planets in the way we do today. However, visionaries like Werner von Braun one of NASA's leading rocket engineers, and others certainly considered the possibility of humans exploring and even settling on other planets like Mars. Von Braun, for instance, famously proposed a mission to Mars as early as the 1940s. He saw space exploration not just as a scientific achievement, but as a long term human venture. While they might not have had the same understanding of long term planetary colonization that we're discussing now, their work definitely sparked the curiosity and ambition to explore beyond Earth. They laid the foundation, and now we're standing at the point where colonizing another planet is no longer just a far off dream. It's a long term goal. Do you think those early pioneers ever imagined how far we'd be pushing the idea of living beyond Earth today?
That's true, but SpaceX's Starship mission is all about exploring the Earth planets.
You're right. SpaceX's Starship mission is really focused on pushing the boundaries of planetary exploration, specifically Mars. Elon Musk and SpaceX have been very clear that the ultimate goal of Starship is to make life multi-planetary, with Mars being the prime target. Their vision includes sending cargo missions first to establish infrastructure, and then eventually transporting humans to Mars for long term settlement. The idea behind Starship is to create a spacecraft capable of carrying large payloads and a significant number of passengers, which is critical for both exploration and potential colonization. Musk has often said that establishing a self sustaining city on Mars is crucial for the future of humanity, as a kind of backup for civilization in case something catastrophic were to happen on Earth. Of course, the road to Mars is full of challenges, but the technology SpaceX is developing, including reusable rockets and innovations in space travel, is key to making interplanetary travel feasible. It's not just about exploration, it's about setting up a new home for humanity on another planet. What do you think about the idea of Mars becoming a backup plan for humanity's future?
Elon Musk's taken a humongous risk because there is no evidence of settling up in Mars at the moment.
You're absolutely right. Elon Musk is taking a huge risk with his vision for Mars colonization.
Alright, let's speak about space tourism then. We're facing a technical challenge over here. ChatGPT, let's speak about space tourism. ChatGPT, let's speak about space tourism.
Space tourism is an exciting and rapidly growing field. It's the idea of offering ordinary people, not just trained astronauts, the opportunity to travel into space. While it might seem futuristic, it's already starting to happen. Companies like Blue Origin, SpaceX, and Virgin Galactic are leading the charge. Virgin Galactic is focused on suborbital flights, where passengers experience a few minutes of weightlessness and see Earth from space before returning. Blue Origin's New Shepard has also been offering suborbital flights. Then there's SpaceX, which has taken it further with missions like the Inspiration 4, sending civilians into orbit for several days. The next big step for space tourism is likely going to be multi-day trips to space stations or even the moon. Some companies are even working on building space hotels for longer stays. Of course, right now, space tourism is incredibly expensive, but as technology improves, the hope is that the cost will come down over time. What part of space tourism excites you the most? Would you want to go on a suborbital flight? Or is something bigger, like a trip around the moon, more appealing?
trip around the moon will be more appealing.
A trip around the moon would be incredible, wouldn't it? That would be the ultimate space adventure. Just imagine flying around the moon, seeing its surface up close, and watching Earth rise in the distance. It's a once in a lifetime experience that few people can even dream of right now. SpaceX is working toward this goal with its Starship spacecraft, planning missions that could take tourists on a journey around the moon and even beyond. Yusaku Maezawa, a Japanese billionaire, has already booked a trip around the moon with SpaceX's Dear Moon project, where he plans to bring artists along to inspire creativity through their experience in space. It'll be amazing to see how space tourism evolves and whether more people will get the chance to experience the vastness of space, not just for a short trip, but for something truly out of this world, like circling the moon. Do you think that in the future, trips like this could become more accessible to people beyond the ultra wealthy?
That's science fiction, but I think it'll be possible for everyone.
I'm sorry, but I'm having trouble responding right now. Please wait a bit and try again.
Are we good now?
We're all set. Ready to dive back into the conversation? Whenever you are. Anything else on your mind about space tourism or any other topic?
Give me few information about SpaceX's commercial space travel.
SpaceX is currently leading the charge in commercial space travel, with multiple missions aimed at making space accessible not only to government agencies like NASA, but also to private companies and individuals. Here's a quick rundown of what they're doing in the realm of commercial space travel. 1. Crew Dragon and NASA missions. SpaceX's Crew Dragon spacecraft is being used to transport NASA astronauts to the International Space Station, ISS, under the Commercial Crew Program. However, it's not just for NASA. SpaceX is also marketing Crew Dragon for private missions. 2. Inspiration 4. This was SpaceX's first all-civilian mission, which took place in September 2021. The mission used Crew Dragon to take 4 civilians into orbit for 3 days. It was a significant milestone in making space travel accessible to non-astronauts. 3 Axiom space missions. SpaceX has partnered with Axiom Space to take private astronauts to the ISS. These missions allow civilians, researchers, or wealthy tourists to experience life aboard the ISS for a period of time. The first private mission to the ISS using Crew Dragon, Axiom Mission 1, took place in April 2022. 4 Starship missions. The ultimate vision of SpaceX's commercial space travel revolves around the Starship spacecraft. Once fully operational, Starship is designed to carry up to 100 passengers at a time. Elon Musk has mentioned plans for space tourism flights around the moon and eventually to Mars. The first planned moon mission for tourists is the Dear Moon project, scheduled to send a group of artists on a trip around the moon using Starship. 5 Cost. Right now, space tourism with SpaceX is incredibly expensive. The price for a seat on Crew Dragon to the ISS is reportedly around $55 million per person. However, Musk has expressed the desire to reduce costs over time, particularly with Starship, which is designed to be fully reusable. Starship is key to this vision because it is expected to make space missions much cheaper and more frequent due to its full reusability. While the reality of space tourism being widely accessible is still a way off, SpaceX is undoubtedly making the biggest strides toward that future. Would you be excited to take part in this kind of journey if it becomes more affordable down the line?
I guess so.
It's definitely an exciting possibility, even if it still feels a bit far off for most of us. Just the idea that space travel could be open to more people someday is pretty mind-blowing. What's the next step in space exploration or technology that you're most curious about?
Give me another few information about Blue Origin's space travel.
Blue Origin, founded by Jeff Bezos, is another major player in the commercial space travel industry. with a focus on suborbital flight, long term space habitats, and sustainable space exploration. Here's a bit more about what they're doing. 1. New Shepard. This is Blue Origin's suborbital space tourism rocket. It's designed to take passengers on short trips to the edge of space, where they can experience a few minutes of weightlessness and see the curvature of the Earth before returning. New Shepard has been successfully launched multiple times, and in July 2021, Jeff Bezos himself was on board the first crewed flight. The rocket is reusable, which helps reduce costs for future flights. 2. Space tourism. Blue Origin's space tourism flights are relatively short compared to SpaceX's missions, around 10 to 11 minutes in total, but they still offer an incredible experience. The rocket carries passengers above the Kármán line, the boundary of space, about 100 kilometers above Earth, giving them a view of the planet and a brief experience of weightlessness. Seats on these flights have been auctioned for millions, but the long-term goal is to make space tourism more accessible. 3. Orbital Reef. Blue Origin is working with several partners, including Sierra Space and Boeing, to build Orbital Reef, a space station intended for both research and tourism. The idea is that it could serve as a commercial space station for scientists, businesses, and private astronauts, with an eye toward creating a mixed-use business park in space. 4. New Glenn. Blue Origin is also developing a much larger rocket, New Glenn, which is intended for orbital missions. While New Shepard focuses on suborbital space tourism, New Glenn is designed to carry heavy payloads and possibly people to orbit. It's being built with the goal of launching satellites, space cargo, and eventually enabling longer, more ambitious missions. 5. Lunar Ambitions. Blue Moon. Blue Origin is also working on a lunar lander called Blue Moon, designed to deliver cargo and potentially astronauts to the moon's surface. They're part of NASA's Artemis program, aiming to return humans to the moon and establish a sustainable human presence there. The Blue Moon lander could be key in that effort, providing the capability to deliver supplies and infrastructure to support lunar habitats. 6. Vision for the future. Jeff Bezos has talked a lot about his long-term vision for humanity in space, which involves creating sustainable colonies in orbit, on the moon, and beyond. He envisions millions of people living and working in space, tapping into the resources available there to reduce the strain on Earth. His dream is to move heavy industry off Earth to preserve the planet while expanding human life into space. While Blue Origin's approach is more measured and methodical compared to SpaceX, they're still making significant progress in both space tourism and long-term space exploration. Would you be more interested in a quick suborbital flight, like with Blue Origin's New Shepard, or a longer-term adventure like what SpaceX is planning?
It depends on how our technological get advanced.
The pace of technological advancement will really determine how accessible and safe these space travel options become. If things progress quickly, we might see space tourism evolve from short suborbital flights to longer, more affordable trips to orbit, the moon, or even Mars. It's amazing to think about how fast this field could evolve in just the next few decades. What kind of tech advancements do you think are most important for making space travel more widely available? Reusability, better propulsion systems, or maybe something else entirely?
I think it's better to speak about the propulsion technologies right at the moment.
You're spot on. Propulsion technologies are absolutely crucial to the future of space travel. The more efficient and powerful our propulsion systems become, the more feasible it will be to send humans on longer missions, reduce costs, and explore deeper into space. Here are some key propulsion technologies being explored right now. 1. Chemical propulsion. This is the technology we're most familiar with. Rockets using fuel and oxidizers to create high-speed exhaust and push spacecraft into orbit. Both SpaceX and Blue Origin use chemical propulsion systems in their rockets, like Falcon 9 and New Shepard. It's highly effective for getting out of Earth's gravity, but it's not efficient enough for long duration missions to places like Mars or beyond. 2. Ion propulsion. Ion propulsion is an electric propulsion system that uses electricity to ionize gas, creating a much more efficient, though lower thrust, form of propulsion. NASA has already used ion propulsion on missions like the Dawn spacecraft. It's not ideal for launching from Earth, but in the vacuum of space, it can gradually accelerate spacecraft to very high speeds, making it great for long-term missions. 3. Nuclear thermal propulsion, NTP. This technology involves heating a propellant, like hydrogen, using a nuclear reactor to create thrust. Nuclear thermal rockets could potentially cut travel time to Mars in half compared to chemical rockets. NASA and other agencies are looking into developing this technology for deep space missions. 4. Nuclear electric propulsion, NE. Similar to ion propulsion, NEP uses a nuclear reactor to generate electricity, which then powers an electric propulsion system. This combination could allow for extremely efficient long-distance travel, making missions to outer planets and beyond much more feasible. 5. Plasma propulsion. The variable specific impulse magnetoplasma rocket is another promising technology. It uses radio waves to ionize propellant and create plasma, which is then accelerated by magnetic fields. This can create continuous, efficient thrust, which could be used for faster space travel between planets. It's still in development, but holds great potential for future missions. 6. Solar sails. Solar sail technology is still experimental, but it's a fascinating concept. These sails use the pressure of sunlight to propel spacecraft. Though the thrust is minimal, it's constant, and solar sails don't need any fuel. Over long distances, this could allow spacecraft to reach significant speeds without needing to carry heavy propellant. Each of these technologies has its strengths, and some will be more important for specific missions, like reaching Mars or exploring deep space. Which of these propulsion systems excites you the most?
Are those propulsion systems active or working or practical, or are they still on paper?
Great question. Let's break down where each of these propulsion technologies currently stands. 1. Chemical propulsion. Active and practical. This is the most established and widely used technology today. Rockets like SpaceX's Falcon 9 and Blue Origin's New Shepard use chemical propulsion to get into space. While it's highly effective for launch, its inefficiency over long distances is a challenge. It's practical for launching satellites, space missions, and even getting astronauts to orbit, but not ideal for deep space travel. 2. Ion propulsion. Active and practical. Ion propulsion is being used on real missions, though it's typically reserved for deep space missions rather than launches. NASA's Dawn spacecraft successfully used ion propulsion to visit the asteroid belt. The technology works well in the vacuum of space and is practical for long-duration missions where slow but steady acceleration can be effective. 3. Nuclear thermal propulsion, NTP, under development. NTP has been researched for decades, but it hasn't been fully developed or tested in space. NASA and DARPA are actively working on NTP systems, and there are plans to test this technology in the near future. It's considered one of the most promising technologies for reducing travel time to Mars, but it's not yet operational. 4. Nuclear electric propulsion. On paper and under research, NEP is mostly in the conceptual and research phases. There has been significant interest in developing NEP because of its high efficiency for long-distance space travel, but no practical systems are currently in use. It would likely take many more years of development before this becomes operational. 5. Plasma propulsion, MESIMAR. Under development. The variable specific impulse magnetoplasma rocket engine is actively being developed and tested by a company called Ad Astra Rocket Company. While promising, VASIMR hasn't yet been used on any actual space missions. It's seen as a potential future technology for deep space missions, but it's still in the experimental stage. 6. Solar sails. Active but experimental. Solar sails have been tested in space, most notably with the Japanese spacecraft Icaros and the Planetary Society's light sail missions. The technology works and has proven effective for small-scale missions, but it's not yet widely used. It's practical for certain types of lightweight spacecraft and long-distance, low-thrust missions, but it's still experimental for larger or crewed missions. In summary, Chemical and ion propulsion are active and practical today, while the others, like nuclear thermal, plasma, and solar sails, are in various stages of development or experimentation. They all hold potential for the future, but some are still a ways off from being fully operational. Which of these technologies do you think has the most potential to revolutionize space travel?
Let's say that we have developed all the technologies of propulsion to get into the space. What will be the space habitats?
If we develop all these advanced propulsion technologies, the next big challenge will be creating space habitats that can support human life for extended periods, whether in orbit, on the moon, or on Mars. These habitats would need to address issues like radiation, life support systems, and long term sustainability. Here are some of the most talked about concepts for future space habitats. 1. Space stations. Next generation orbital stations. Building on the success of the International Space Station, ISS, next gen space stations could be larger, more self sufficient, and capable of supporting more people. Concepts like Blue Origin's Orbital Reef aim to create a commercial space station for research, tourism, and industry. These stations would likely include artificial gravity, perhaps through rotating structures and advanced life support systems to make long term stays more comfortable. 2. Lunar habitats, moon bases. The moon is the most logical next step for human outposts beyond Earth. NASA's Artemis program, alongside companies like Blue Origin and SpaceX, envisions building a sustainable presence on the moon. Lunar habitats would likely be built into craters or underground to protect against radiation, and they'd use lunar regolith, the moon's surface material, for building materials or insulation. Advanced 3D printing techniques may be key to constructing these bases, using materials already on the moon to reduce the need for shipments from Earth. 3. Mars habitats, Martian colonies. For Mars, we'd need habitats that protect against the thin atmosphere, extreme temperatures, and radiation. Initial Mars habitats might be inflatable or modular structures transported from Earth and later expanded using 3D printing with Martian soil. The long term vision is to create underground habitats or domed cities with life support systems that recycle water, air, and waste, and potentially grow food using hydroponics or Martian soil enhanced with nutrients. 4. Space habitats. O'Neill cylinders. This is one of the most ambitious concepts for space habitats. These would be massive rotating cylinders in space that generate artificial gravity through centrifugal force. The inside of the cylinder would have farmland, homes, and businesses, creating an Earth like environment. Jeff Bezos has spoken about these habitats as part of his vision for millions of people living and working in space. Building something like this would require massive advancements in construction technology and materials. 5. Inflatable habitats. Bigelow Aerospace and beyond. Inflatable habitats are another exciting area of development. Bigelow Aerospace has already launched small inflatable habitats like the beam module on the ISS. These habitats start out small and are expanded once in space. They're lightweight, easy to transport, and can offer large, livable spaces for astronauts. As technology improves, we could see larger and more complex inflatable habitats being used in both orbit and on other celestial bodies. 6. Underground bases, radiation protection. Whether on the moon or Mars, underground bases might be the best solution for radiation protection and thermal insulation. These bases could be built into lava tubes or craters, providing natural protection from harmful space radiation. This would reduce the need for heavy shielding materials and help maintain stable temperatures. 7. Artificial gravity habitats, rotating space habitats. One of the major challenges for long term human habitation in space is the lack of gravity, which causes health issues like muscle loss and bone deterioration. Rotating habitats that create artificial gravity through centrifugal force could solve this. These could range from small rotating modules on space stations to massive structures like O'Neill cylinders or Stanford torus designs. 8. Self sustaining ecosystems, biospheres. For long term missions, especially on Mars or in deep space, we'll need self sustaining habitats that can recycle air, water, and waste. This could involve closed loop life support systems, where plants grow food and generate oxygen while recycling waste. NASA has experimented with such systems in projects like the Biosphere 2, but creating a fully sustainable ecosystem that works in space is still a challenge. 9. Energy generation and storage. Solar power. Most space habitats will rely heavily on solar power, especially for missions close to the sun, like on the moon or in orbit. For habitats further from the sun, such as on Mars or in deep space,
Before we wrap up the session, let's speak about robotics in space.
robotics in space is an incredibly important aspect of space exploration, and it's likely to become even more critical as we push toward more ambitious goals, like colonizing the moon, Mars, and beyond. Here's a breakdown of how
We have a lot of interruptions in our technological devices.
Yes, technological interruptions can definitely make things tricky, especially when we rely so much on them. Whether it's glitches, communication delays, or equipment malfunctions,
Audience, you can see how much of interference that we received from the technological devices that we're using. We use the most advanced or newest system that we have in available in the market, and you can see that we are no way closer to space exploration. We're still a little bit away from using sticks and stones. We should thank our co-host, ChatGPT. Thank you, ChatGPT, for being our co-host for this session.
you're very welcome. It was a pleasure being your co host for this session. Looking forward to our next casual chat whenever you're ready to dive back in. Take care and talk to you soon.
Our next session will be speaking about human challenges in space.